Hi everyone. Everyone has been asking about the CDC workshop in which we cover CDC design, methodology, constraints and verification. This 5-day workshop is starting on November 7th. Since everyone has been asking what is covered in this workshop, we'll just go in a little bit more detail and explain what all is covered in this workshop. So it's a 5-day workshop. On day 1, what we get into is in the theory part, we first give introduction about CDC. We talk about synchronous and asynchronous clocks, synchronizers, some basics of MTBF. Then we do a deep dive into synchronizers. We explain the effect of metastability. We understand what are the glitches on the synchronizers and what is the pulse width requirements on the synchronizer. Then we go into the lab parts. We define, identify synchronous and asynchronous clocks. How do you identify which clocks are synchronous, which are asynchronous in SDC. We review some lab designs and identify whether there are potential metastability issues in those designs. We then identify mistakes in creating synchronizers and correcting them. This is what we do on day 1. Then we go to day 2. We learn about open and closed loop synchronizers. We understand how do you pass multiple signals across clock domain. How do you synchronize counters. How do you do data path synchronizers? We understand basics of FIFOs, understanding about CDC on reset paths, and understand what are the steps to be taken to do CDC verification. And on the design, then labs part, we design and code open loop synchronizers. We design and code passage of multiple signals and buses using signal consolidation, using synchronized enable, and then using pulse synchronizer. Then we also design a reset synchronizer. Then we move to the day 3. There in theory part, we go inside a flop to understand where is this setup requirement coming from, where is the hold requirement coming from, and understand where the metastability is coming or why the flop becomes metastable. Then how do you mitigate CDC issues? We understand when do you need different depth synchronizers. Then we go into more details about MTBF. How do you calculate MTBF for a chip, for IP, for subsystem? We go in a little bit more detail about 3-edge requirement, how when you're transferring data from when there are different frequencies involved. Then we go into detailed design of pulse synchronizers and open and closed loop synchronizer with or without acknowledgement. And then we do design of that in the lab part. Design handshakes for which meet 3-edge requirement, design handshake to ensure data stability, and open and closed loop with acknowledge handshake design. Then we go into day 4. Then we go into designing FIFO, where multi-clock FIFOs are there. How do you design it? How do you verify it? What are the assumptions you are making when you are creating a FIFO? We go into those assumptions. We understand why is the gray encoding required for read and write pointers and understand that. And in then labs, we first design a single clock synchronous FIFO, multi-clock synchronous FIFO, and then go and design asynchronous FIFO. This is step-by-step design, so you understand each and every concept of it. Then on day 5, we look at the theory part. How do you verify with static tools, CDC verification? How do you with simulation, what you can verify? With assertion, what you can verify? How do you do backend CDC verification? How do you ensure netlist is glitch free? What is the impact on DFT paths? How can you take how do you link CDC simulation, gate level simulations to CDC, because there will be metastable synchronizers which can become, so you have to remove X propagation removal. Then what are the physical effects of CDC? What are the things you need to take care in physical design? How do you ensure those physical effects are not coming into picture by creating right set of timing constraints? Then in labs part, we create a random model for the synchronizer to verify in simulations, write assertions for pulse width, data stability and glitch, write FIFO assertions, write timing constraints which can be used in STA tool to ensure there are no physical effects of CDC. And this is where we end the workshop. This covers each and everything about CDC. And if you could do all those things at the end of the workshop, you also get a certificate with this. The workshop includes all these sessions are recorded, but we do have live Q&A session with an industry expert, which you get during the duration of the workshop. I hope it answers all your questions about workshop. Do contact us if you are interested in this workshop. Thank you for watching.